Good afternoon everyone. Today we are in the 52nd session of Quantitative Technique 1 prescribed for BCom 3rd semester affiliated to Vijayanagara Sri Krishna Devara University, Ballari. In earlier sessions we have discussed about meaning and definition of skewness, measures of skewness. ಅಂದರೆ ಹಿಂದಿನ ಸೆಷನ್ಗಳಲ್ಲಿ ನಾವು meaning of skewness and measures of skewness ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ in earlier sessions. Here the meaning and definition. Okay, when the data set is not a symmetrical distribution, it is called a skewness. If the data is not symmetrical, that is treated as, or the distribution is considered as the skewness, and such a distribution could either be positively skewed or negatively skewed. That is treated as the skewness. When the set of data is not a symmetrical distribution, it is called a skewness, and such distribution either that may be a positively skewed or negatively skewed. Positive ಅಥವಾ negative ಅಂತ ನಾವು ಟ್ರೀಟ್ ಮಾಡ್ತೀವಿ. This is the meaning of skewness and definition. According to Craxton and Cowden, when a series is not symmetrical, it is said to be asymmetrical or skewed. When a series is not symmetrical or it is symmetrical, it is said to be asymmetric or skewed. This is as per the words of Craxton and Cowden and Morris Hamburg. Skewness refers to the asymmetric or lack of symmetry in the shape of frequency distribution is also considered as the skewness. These are the definitions given by Craxton and Cowden and Morris Hamburg. This is relating to earlier session. And learning objective. The aim of this chapter is to make students to understand measures of skewness, Karl Pearson's coefficient of skewness and Bowley's coefficient of skewness. These are the learning objectives of this particular chapter. In this chapter, the students can understand the measures of skewness. What are the measures of skewness? And that Karl Pearson, what is the Karl Pearson's coefficient of skewness and Bowley's coefficient of skewness. ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಚಾಪ್ಟರ್ನಿಂದ ಸ್ಕ್ಯೂನೆಸ್ ಅಂದ್ರೇನು, ಅಗೇನ್ ವಾಟ್ ಆರ್ ದಿ ಮೆಜರ್ಸ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್ ಆ್ಯಂಡ್ ಕಾರ್ಲ್ ಪಿಯರ್ಸನ್ಸ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್ ಅಂದ್ರೇನು, ಅಗೇನ್ ಬೌಲೀಸ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್ ಅನ್ನೋದನ್ನು ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಚಾಪ್ಟರ್ ಮುಖಾಂತರ ನಾವೇನು ಮಾಡ್ಬೋದು, ಕಲಿಬೋದು. ಆ್ಯಂಡ್ ಲರ್ನಿಂಗ್ ಔಟ್ಕಮ್ಸ್. ಆಫ್ಟರ್ ಕಂಪ್ಲೀಷನ್ ಆಫ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ unit, students can be able to apply to sample population data by differentiating normal and abnormal distributions with regard to dispersion and skewness. After this unit or after completion of this unit, students can be able to apply to sample population data by differentiating normal and abnormal distributions with regard to distribution and skewness. Very one particular chapter complete ಆದ ನಂತರ students can be able to apply how to apply sample population data by differentiating normal and abnormal distribution, especially with regard to dispersion and skewness ಮತ್ತು ಡಿಸ್ಪರ್ಷನ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ನಾರ್ಮಲ್ ಮತ್ತು ಅಬ್ನಾರ್ಮಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಯಾವ ರೀತಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡ್ಬೋದು ಅನ್ನೋದನ್ನು ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಚಾಪ್ಟರ್ನಿಂದ ನಾವು ಕಲಿಬೋದು. ದಿಸ್ ಇಸ್ ರಿಲೇಟಿಂಗ್ ಟು ಲರ್ನಿಂಗ್ ಔಟ್ಕಮ್ಸ್. Session 52, Karl Pearson's coefficient of skewness under individual and discrete series problems. ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಸೆಷನ್ನಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಕಾರ್ಲ್ ಪಿಯರ್ಸನ್ಸ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್ ಅಂಡರ್ ಇಂಡಿವಿಜುವಲ್ ಆ್ಯಂಡ್ ಡಿಸ್ಕ್ರೀಟ್ ಸೀರೀಸ್. ಅಂದರೆ ಅರ್ಲಿಯರ್ ಸೆಷನ್ನಲ್ಲಿ ನಾವು ನೋಡಿದ್ವಿ ಮೆಜರ್ಸ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್ನಲ್ಲಿ ಅಬ್ಸಲ್ಯೂಟ್ ಮೆಜರ್ಸ್ ಆ್ಯಂಡ್ ರಿಲೇಟಿವ್ ಮೆಜರ್ಸ್ನ ನೋಡಿದ್ದೀವಿ. ಅಗೇನ್ ಅಬ್ಸಲ್ಯೂಟ್ ಮೆಜರ್ಸ್ ಆ್ಯಂಡ್ ರಿಲೇಟಿವ್ ಮೆಜರ್ನಲ್ಲಿ ಕಾರ್ಲ್ ಪಿಯರ್ಸನ್ಸ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್ ಒಂದು ಬಂದಿರುತ್ತೆ, ಬೌಲೇಸ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್, ಕೆಲ್ಲಿಸ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್. ನಾವೀಗ ಕಾರ್ಲ್ ಪಿಯರ್ಸನ್ಸ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್ನ ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಚಾಪ್ಟರ್ನಿಂದ ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಸೆಷನ್ನಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಕಲಿತೀವಿ. under individual and discrete series problems. Here the Karl Pearson's coefficient of skewness. Karl Pearson's coefficient of skewness, this method is most frequently used for measuring skewness. In order to measure the skewness, Karl Pearson coefficient of skewness is most frequently used technique. The formula for measuring the coefficient of skewness is given by Skewness is equal to mean minus mode divided by standard deviation. Therefore, Karl Pearson's coefficient of skewness under individual series. Example, first one, compute Karl Pearson's coefficient of skewness x 50, 55, 45, 65, 70, 45, 75 and 35. This is the problem. From this we need to compute the Karl Pearson's coefficient of skewness. ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್ ನಿಂದ ನಾವೇನು ಮಾಡ್ತೀವಿ, Karl Pearson's coefficient of skewness ನ ಕಂಪ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. Again, calculation of Karl Pearson's coefficient of skewness. Karl Pearson's coefficient, calculation of Karl Pearson's coefficient of skewness. X is equal to x minus x bar, again x square. X is x 50, 55, 45, 65, 70, 45, 75, 35. ಇಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಿದ್ದೀವಿ, x 55ನ ನಾವೇನಂತ ಟ್ರೀಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Again x bar mean, first we need to compute the mean from this data. Therefore mean is equal to sigma x divided by n. For mean is equal to sigma x divided by n. For sigma x is equal to 440 divided by n is equal to 8 values, 1, 2, 3, 4, 5, 6, 7, 8 values. Therefore sigma n mean is equal to sigma x divided by n. 440 divided by n is equal to 55. Therefore x is equal to x minus x bar, or mean. Therefore x is 50, 50 minus 55, that is minus 5. Again 55 minus 55, 0. 45 minus 55, minus 10. 65 minus 55, plus 10. 70 minus 55, 15. 45 minus 55, minus 10. 75 minus 55, 20. 35 minus 55, minus 20. Again we need to compute x square. Minus 5 whole square is equal to 25. 0 square 0, minus 10 square 100, plus 10 square 100, 15 square 225, minus 10 square 100, 20 square 400, minus 20 square 400. Therefore sigma x square is equal to 1350. That is 25 plus 100, 125 plus 100, 225, 225 plus 225, 450, 450 plus 100, 550 plus 400, 950, 950 plus 400, 1350 is the summation x square or sigma x square. Therefore therefore standard deviation is equal to square root of x square sigma x square divided by n. Therefore standard deviation is equal to square root of 1350 divided by 8. Square root standard deviation is equal to 13, approximately 168.75. the square root is 12 point something, approximately 13. Therefore mode is equal to most repeated value is 45, that is 2 times z is equal to 45. Therefore formula for computing skewness of Karl Pearson's coefficient of skewness is mean minus mode divided by standard deviation. Mean is equal to 55 minus mode 45 divided by standard deviation 13. 55 minus 45, 10 divided by 13. Therefore skewness is equal to 0.769 or 0.77. Okay, in this problem first we need to compute mean, mode and standard deviation. Now in particular problem ಅಲ್ಲಿ mean ನ compute ಮಾಡಬೇಕು, ಅದರ ಜೊತೆಯಲ್ಲಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿವಿಯೇಷನ್ ನ ಕಂಪ್ಯೂಟ್ ಮಾಡ್ತೀವಿ ಮತ್ತು ಮೋಡ್ ನ ನಾವು ಕಂಪ್ಯೂಟ್ ಮಾಡಿರ್ತೀವಿ. ಇವೆರಡನ್ನು ಇಲ್ಲಿ ಫಸ್ಟ್ ನಾವು ಮೀನ್ ನ ಕಂಪ್ಯೂಟ್ ಮಾಡಿದ್ವಿ. ಮೀನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್. ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಇಸ್ 440 divided by 8 is equal to 550. Again standard deviation is equal to sigma x square divided by n. For standard deviation is equal to sigma x square, 1350 divided by n is 8. For standard deviation is equal to square root of 168.75, that is 13. Mode is equal to most repeated value is 45, that is 2 times. Z is equal to 45. Skewness is equal to mean minus mode divided by standard deviation. Skewness, Karl Pearson's coefficient of skewness is equal to 55 minus 45 divided by 13. 55 minus 45 Sk is equal to 10 divided by 13, 0.769 or 0.77. Next, then Karl Pearson's of coefficient of skewness under discrete series. For compute Karl Pearson's coefficient of skewness under discrete series. Wages and number of persons. Wages 15, number of persons 3, wages 20, number of persons 19, wages 25, number of persons 16, 30, 25, wages 35, number of persons 4, 40, wages number of persons 6, 45, wages 45, number of persons 5. Therefore mean is equal to sigma fx by n. Again, standard deviation is equal to square root of sigma x square divided by n. Mode is the highest frequency is 25, and corresponding wages are x value becomes z is equal to 30. Calculate the calculation of Karl Pearson's coefficient of skewness under discrete series. Therefore wages 15, 20, 25, 30, 35, 40, 45. Number of persons 3, 19, 16, 25, 4, 6, 5. For n is equal to 78. 3 plus 19, 22 plus 18 plus 16, 38 plus 25, 63 plus 4, 67 plus 6, 73 plus 5, 78. Sigma. Next fx, f into x, f3 into 15, 45, 19 into 20, 380, 16 into 25, 400, 25 into 30, 750, 4 into 35, 140, 6 into 40, 240, 5 into 45, 225. Therefore sigma fx is equal to 2180. Therefore mean is equal to sigma fx divided by n. Mean is equal to 2180. Sigma fx divided by n is 78. Mean is equal to 27.94 or 28, approximately 28. For standard deviation, x is equal to x minus mean. My x is 15 minus 28 minus 13, 20 minus 28 minus 8, 25 minus 28 minus 3, 30 minus 2, 30 minus 28 2, 35 minus 28 7, 40 minus 28 12, 45 minus 28 17. Therefore sigma x square minus 13 square is 169, minus 8 square 64, minus 3 square 9, 2 square 4, 7 square 49, 12 square 144, 17 square 289. F into x square 3 into 169, 507, 19 into 64, 1216, 16 into 9, 144, 25 into 4, 100, 4 into 49, 196, 6 into 144, 864, 5 into 289, 1445. Therefore sigma fx square is equal to 4472. Standard deviation is equal to square root of sigma fx square divided by n. Standard deviation is equal to square root of 4472 divided by 7. Standard deviation is equal to square root of 57.33. Standard deviation is equal to 7.57 is the standard deviation, and mean is equal to, again mode is the highest frequency is 25, and the corresponding wages are x value becomes mode z is equal to 30. Mean is equal to 28. Standard deviation is equal to 7.57. Z is equal to 30. Skewness is equal to mean minus mode divided by standard deviation. Mean 28 minus 30 divided by 7.57. Standard deviation is equal to skewness is equal to minus 0.6. Summary, as well already discussed and learned today on diagrammatic and graphical representation as below. Karl Pearson's coefficient of skewness under individual and discrete series problems. In multiple choice questions, the distribution in which mean is equal to 60 and mode is 50 will be option A, symmetrical, option B, positive skewed, option C, negative skewed, option D, none of these. Second one, if mean is less than mode, the distribution will be option A, positively skewed, option B, negatively skewed, option C, symmetrical, option D, none of these. And third one, in symmetrical distribution, mean, median and mode are option A equal, option B different, option C 0, option D none of these. Fourth one, if mean, median and mode are equal, then distribution will be option A positive skewed, option B negative skewed, option C symmetrical, option D none of these. And fifth one, the value of mean, median and mode can be option A sometimes equal, option B never equal, option C always equal, option D none of these. For first one, B, the distribution in mean is equal to 60 and mode is 50 will be positively skewed. For second one, option B, if mean is less than mode, then distribution will be negatively skewed. For 3, A, in symmetrical distribution mean, median and mode are equal, and if mean, median and mode are equal, then the distribution will be symmetrical. And last one, the value of mean, median, mode can be sometime equal. References: S.P. Gupta, Sultan Chand and Sons publication.